Bismillahirrahmanirrahim. So dear students, let's talk about the assignment of section C. The related problems are problem number 3, 7, 11, 16, 20 and 23rd from our assignment sheet. And here is the first problem. In this problem we have a cantilever beam subjected to two point movements or couples of magnitude 6 kilonewton meter and 10 kilonewton meter. Their locations are given. In this case there is no force acting on the beam, only couples are there, so RA will be equal to 0 and there will be only MA. I have gone through the calculations and the reactions RA and MA both seems to be fine. Then how many portions should we have for this beam? 1, 2, 3 portions should be there, A, B, B, C and CD. If you look at the shear force diagram and bending moment diagram, the shear force will be equal to 0 because there is no reactive force and there is no applied force. So shear force is 0. And bending moment diagram, we have 4 kilonewton meter moment here, and then we have 6 kilonewton meter and 10 kilonewton. So both these diagrams, shear force diagram, bending moment diagram, are correct. And in the elastic curve, I just have one observation, that this part seems to be straight. So in your elastic curve, like the trend of the beam should appear to be correct. So this beam will be sagging throughout its length. So I have just slightly edited this, because the entire bending moment diagram is positive, so the entire beam should be sagging. Next problem is a simply supported beam subjected to 2 point loads and 2 couples. The point loads are acting exactly at the supports, and the couples are also acting at the supports. Excuse me. The reactions are 4.9 kilonewton and 10.1 kilonewton at support A and support B respectively. And then if we look at the shear force diagram and bending moment diagram, shear force diagram is correct. Shear force will be constant. There is no load present in between. And bending moment diagram will also be a constant because there is one couple acting here and one couple acting here. Those couples are not marked here. So this diagram, both these diagrams seems okay to me. And the elastic curve, the entire beam's bending moment diagram is positive, so the elastic curve should be sagging, so this is also fine. Next is this overhanging beam subjected to a VDL in the overhang part. Reactions are correct. And then how many portions should we consider? I think we should consider 2 portions, portion A, B and B, C. If we look at the shear force diagram and bending moment diagram, 5 kilonewton force, the reaction is in the downward direction, and here the reaction is in upward direction. So we have negative shear in this part, and then this 20 brings it to 15, and the magnitude of applied load is increasing. So the slope of shear force diagram should also be increasing. This diagram is correct, and the bending moment diagram should be first degree, and this ordinate is not minus 450, it is minus 50. In the calculations it is calculated correctly, but this is just a mistake while writing it down here. So minus 50 is the correct value. As the slope is increasing or the magnitude is decreasing, so this slope should be decreasing. And this is 3rd degree, it's right, the degree is written. So both these diagrams, the shear force diagram and bending moment diagram, both the diagrams are correct. The entire bending moment diagram is negative, so the curve should be hogging, and that's also fine. Yes, that's fine. Okay. All right, now let's move to the next problem. This is a cantilever beam, and it is subjected to a couple and 2 forces. These two forces are acting at the same point, and they are in opposite directions, so they will simply cancel out each other, like 5 and 10 in the upward direction, 5 kilonewton in the downward direction. So this case situation is just similar to a 5 kilonewton load acting at this point C in the upward direction. So I've checked the calculations, the reactions are correct, and if you look at the shear force diagram and bending moment diagram, shear force diagram seems correct. Similarly, bending moment diagram is also correct. Again, I have an observation related to the elastic curve. This elastic curve seems like straight, which is not true. The entire bending moment diagram is positive, so this elastic curve should be sagging. As we have discussed so many problems on this topic, so I'm just quickly going through these problems, and I have gone through this assignment beforehand, and I think the solution is correct. So if you guys find anything that you think that is not correct, so we can talk about that in the class. This is an overhanging beam subjected to a couple. There is only movement present, there is no applied load, but still there will be reactions because it is not a cantilever beam. It does not have a fixed support that can generate a movement. So this movement will be balanced by these two reactions. One reaction should come out to be in the upward direction and one should be in the downward direction. That's how it is, minus m naught over L, and this is plus m naught over L. And if I look at the diagram, then shear force diagram and bending moment diagram, shear force diagram is entire negative and bending moment diagram is also correct. First degree, and I have just one observation about the elastic curve. It is right, in this negative part the elastic curve would be hogging, and then in the positive part it will be sagging, and in the remaining part where there is no bending moment, there should be no hogging or sagging. If you look at the originally drawn elastic curve, it seems like hogging, but it won't hog because there is no movement present here to hog this. So we will just hog here and the second part sag, and then it will go straight. And yeah, this was the second last problem. And then last problem number 23, we have a cantilever beam subjected to UDL at the extreme end, and let me see, its reaction calculation is correct. So mark it here. Yeah, this is correct and this is also correct. And if I look at its shear force diagram, bending moment diagram, I have gone through these diagrams. These diagrams are also correct. So if your solution is not matching with the solution given here, except the mistakes that I have pointed out, if your solution does not match with this solution and you are still not clear about the correct way, then we can talk about in our class discussion. Shear force diagram, bending moment diagram, and elastic curve all are correct for this case. So we'll stop our recording at this point. Thank you.